Hi, I'm Kian. In this video, I'm going to show you how to solve a very well-known partial differential equation. So this partial differential equation here is known famously by the name of the Burgers equation, which basically describes the flow speed or the speed of a fluid along a pipe in different locations. So the function that we work with in this case is a two-variable function in terms of time, t, and position x. So you have to solve this equation. So you have a two-variable function, and then we take the partial derivative with respect to t, and that equals the function, the original function, times the partial derivative with respect to x of the function. So for these types of partial differential equation, if you have seen my previous videos, I've solved different examples of partial differential equation, different well-known examples. We can actually let the solution to this to be kind of a combination of two functions, a product in this case of two simpler functions. So we let f, which is a function of t and x, to be the product of f of t and g of x. F of t is a basically single variable function only in terms of t, and g of x is again a single variable function but in terms of x. So basically if we multiply them, we get a two variable function in terms of t and x. And the aim of this method is to basically turn a PDE, which is usually harder to solve, to an ODE. PDE is partial differential equation and ODE is ordinary. Ordinary, the difference is that there's no basically partial derivatives. We have only normal derivatives, which we are usually used to when solving differential equations. So let's go ahead and kind of fill in the gaps. So based on what we introduced our function to be, f prime of t is just taking the derivative of this with respect to t and treating everything else as constant. So here we would have f prime of t times g of x. So g of x stays the same because it's basically treated as a constant because it's not in terms of t. And this is equal to f, which is f of t times g of x. F of t times g of x. And then times f prime of x, or fx, the partial derivative, which is f of t, so it stays the same. In this case, the t stays the same, the function of t, and we take a derivative of g of x, so we get g prime of x. Now here we can see, to make our life simpler, we can actually cancel out the g of x's, and the reason is because we're working with an example. The function we're working with basically describes the flow speed in terms of time and position. So we don't really want to have a general solution that is zero, because if we basically consider g of x to be zero, then the whole function would be zero. And we don't really want that to happen, even though it is still possible. We're going to kind of neglect that. We're going to say that g of x cannot be zero. So in this case, we can cancel out the g of x's without kind of having any problem of dividing with zero. And to clean this up, I'm going to divide basically both sides by f of t times f of t. So we have one side in terms of t and one side in terms of x's. So basically we get f prime of t and I'm going to write f of t times f of t as f of t squared and this is equal to g prime of x. And basically, you can use common sense to think that when we have a function of t in this case, so we're taking the derivative, we're dividing by the function squared, we get something in terms of t. On the right-hand side, we basically take a function of x, take a derivative, we get something in terms of x. The only way these two can equal each other is for both of them to equal a constant. We call it c. That's basically a well-known method in solving partial differential equation. I've used this a lot in the past videos where I solve partial differential equation in terms of kind of separable. We call these separable because we can kind of separate the variables. And it kind of makes sense because the only way something in terms of t can equal something in terms of x, two different variables, is to both of them equal a constant. Now what we have made is two simpler ODEs, or ordinary differential equations. So one of them would be f prime of t over f of t squared is equal to this constant c, and the other is g prime of x is equal to the constant c. And then when we solve both of them, we can just multiply the answers and we get our solution. So let's go ahead and solve those. So I'm going to choose red. So for the first one, number 1, we're going to solve this. So I'm going to change the notations a bit. I'm going to call it dy dt, if you don't mind, y being the function, or f. So dy dt, and then I'm going to write this as times 1 over y squared. And this is the same as f of t squared. In this case, f of t is the y, is a function. You have y squared, and then this is equal to the constant c. So this is a kind of a simple ordinary differential equation. We can take the integral of both sides. So if we do that, we take the integral, we get negative 1 over y is equal to, and then the right hand side is in terms of t because we're multiplying by t. So we get ct, c times t, and then we add a constant. We can call it k. And since we want our answer, we want to find y basically, because y is the f of t we're looking for, we can multiply both sides by -1 and take the reciprocal to find that y is in fact equal to, I'm just going to call it 1 over, and then the -1 is being multiplied by d, so negative ct minus k. So that's equal to f of t. Now we go ahead and solve the second ODE. Use yellow. So the second one is very easy because we just have g prime of x is equal to c. I'm going to call g prime, if you don't mind, dy. The y's aren't the same, but since we're used to kind of this notation when solving differential equations, I'm just going to use it for now. dy dx, y being the g of x in this case, and x being the variable. And so again, we multiply by dx, we can integrate both sides. Again, this would be in terms of dx, then this would go away. Here also, this would be in terms of dt, and then this would go away. And what we are left off is basically y, which is equal to the g of x, the function in terms of x, is equal to the integral of that, which is cx, and then we want to add a constant, we can add plus b. So now you have found the two parts of our solution. One of them is this, cx plus b, one of them is this, 1 over negative ct minus k. Our last thing to do is to multiply them, and it's pretty easy because we know that f, I'm going to call it f of t comma x, being the function of two variables, is the product of these. So cx plus b times 1 over that is just cx plus b, and then all over negative ct minus k. And if you want to check that with, again, taking the derivative using the quotient rule, for the part that is, so we don't really need to take the quotient rule, we can use power rule. But if you do that, you'll see that if you plug it into the original equation, you get equality on both sides. So this is in fact our solution. Thanks for watching. I hope you enjoyed it, and bye-bye.